Hello, good day, my dear students. Today I'm very excited. I'm going to take class of DBMS, Database Management System. Really, this is a very important class for the students who are learning software and they are also learning software languages like C, C++, Java, .NET, Oracle, Python, right? So when they start learning any computer language, then definitely they have to store the data also, because database management system like Oracle, you must have heard SQL, SQL Server, all these are called database management system. But first question arises, what do you mean by database management system, right? So database management system is a software program, right? It's a software system, right? That helps in managing the data, retrieving the data, and it allows us to work on the records, work on the data. And the very important thing is that database management system is an entity. It works as an entity between end user and the database, which allows you to add the data, update the data, or delete the data from the database management system. Right. And you know very well that in database, the first thing is that table. We have to create the table, right? And for that purpose, before making a table, we should know about normalization, first normal form, second normal form. What do you mean by all these? Right? We'll continue this one, but today is the first class, so I would like to tell you something about the computer also, because maybe possible that some students, they are not familiar about particular topic, particular terms, and I would like to tell you about, first of all, computer exactly. What is a computer exactly? You know, simply we say computer is an electronic device and data processing machine by which within a fraction of seconds we can do calculation, millions, we can calculate millions and billions of data, right? So, as I told you, what is computer? I told you computer electronic system, computer electronic device, right? Now question comes, what do you mean by data? Data is a form, facts and figure, right? And it's a raw material that after processing gives the final information. Whenever we talk, we have to learn about two things, hardware and software also, you must have heard. So what do you mean by hardware and what do you mean by software? So simply you could say hardware is a physical component of a computer that can be repaired, that can be touched, right? Like physical components of computer is called hardware, like monitor, keyboard, okay, and CPU. CPU means that's called box, cabinet box. And what do you mean by software? Software is a programming part of the computer, right? Software is a programming part of the computer which cannot be, you can say that, modified. Software can be modified, but it cannot be touched. Software is a programming part of the computer that cannot be touched, repaired. It can be modified, that programming can be modified, right? Now, could you tell me some, just like present you told me definition of computer also, definition of hardware and software also. Now one thing you tell me, what do you mean by manware? Because I have heard hardware also, software also, what is called manware also, right? Of course, hardware and software that is handled by the man, that's why it's called manware also, right? Together we should have, right? Now one question comes in mind. When was computer designed, developed? Could you tell me what before 5000 BC years ago, did we use computer that time? No. 5000 BC, before Christ, we were not familiar about how to count. Our forefathers, they used to count with the help of pebbles, concrete, right? 1 to 9, they used to count only. By just giving the, that horizontal line like only. They didn't know about how to count like that one. But later on, abacus came and he designed a slate. These types of slate you could see in the hands of students going to school in the villages generally. And that slate is half is slate and half some bits are attached over there, by which you could move and you could play and you could calculate also. So addition and subtraction both are possible with the help of that one, right? So this is called abacus. That's why on the name of abacus, this is called abacus computer also. And in China it is called soroban, right? So that was the computer I told you. And after that, Blaise Pascal came, that's called Pascaline. And Herman Hollerith also came. Many persons came, they designed the computer, the architecture, they gave the architecture of the computer, right? And now you tell me about something about the generation of computer. Well, whenever we talk about generation, then generally it is considered that in India, computer started in 1943, right? And generally 10 years is called one decade and 100 years is called one century. Generally, it has been considered that after every 10 years, the technology gets changed. As I am giving an example, as in it started in India 1943, and within 10 years, that time the computer that was designed, right, that shape and size used to be very big, like a room, like my dear friend. And the language we were using, that was machine language that time. And machine language, you know very well, that's made up of 0 and 1, right? So only that time machine language was used and computer used to be very huge and it would work very slowly. That was the thing. That was in first generation. And machine language made up of 0 and 1, I told you, binary digits. So it was difficult for a human being, it was very difficult to calculate millions and billions of, right? When we talk about 0 and composition of 0, 1, when we do that. So our scientists decided to do something different one, and they invented another one, assembly language. That was machine language. In second generation language, after 10 years, another generation started. In that, in first generation, we were having a vacuum tube, right? In first generation, at the place just like we are using at present, we are using processor, etc. So that time we were using vacuum tube in first generation. Second generation, transistor was invented, right? So they started using dozens of transistors, etc. in second generation. And by using second generation transistor, by using the transistor, computer shape and size became smaller, my dear friend, right? And the language that was used, that was assembly language, my dear friend. Right. You know very well assembly language in just like move 10 to X, where X is called registers and 10 is called value. So move, MOV, move, English-like word, right, that we started using in that assembly language. So it was a little bit easier than machine language for us. Right. So assembly language was that, but one thing, machine language and assembly language both are called low-level language, low-level language, because both are dependent on the architecture, hardware. Both are depends on hardware, my dear friend, right? And our problem was not sorted out. So third generation started, right? As I told you, in second generation, we started using assembly language. And computer shape and size become smaller, right? Now third generation, after 10 years, as I told you, 10 years, we this time chips we started inventing. Chips means collection of transistors, right? IC you could say, integrated circuit. In third generation, we started using IC, integrated circuits, collection of transistors. And with the help of that, computer shape and size became smaller also, right? Computer shape and size became smaller. And the language we started using, that was high level language, my dear friend. High level language. This language was written, used to be written in English only. So it was very easy for everybody to understand, right? Like I'm telling you, BASIC, COBOL, Pascal, Fortran, C, C++, Java, .NET, all these are called high level language, my dear friend. Because everything that is written in English language, means source code we write English language and we have to convert this into machine code. Source code can be converted into machine code, object code, right? That we have to convert. So for that purpose, because computer understands only machine language and we write generally in English, in high level language, so we require translator, my dear friend. And you must have heard about translator. Whenever we talk about translator, then we call assembler, one is called assembler also, and second is called compiler, assembler, or interpreter. You must have heard. So what's the difference between compiler, assembler, and interpreter? Could you tell me? Anybody? Compiler means someone who compiles the whole program at a time. Suppose that you have written 4 pages. So all the program in a single way, within a fraction of seconds, it translates all these and gives the result. That's called, what do we say that is called? Compiler. What do you mean by assembler? Assembler means assembly language. Because I told you that assembly language is also low level, but computer doesn't understand that one. So it has to be converted into machine language also, my dear friend. So for that, assembler is the software that converts assembly language into machine language. Assembler is also a software, translator software, right? And interpreter, it interprets sentence wise. Like one sentence, first one, it will read, and after that it will tell you the errors. Again, after correcting it, it will tell you second one, slowly and slowly it will proceed further. That's why interpreter method. Got it? Thank you very much. I will continue in second day. Merci beaucoup.